that the future is electric, but we wanted to see how did the electric vehicle evolve during the last few years, and what was the cause, what leads to this boom. So in our term project, we tried to analyze the electric vehicle growth and the trend during the last recent years. So to start with, uh, so there's some interesting facts about electric vehicle. So between 2010 to 2020, I, alone in United States, we saw a rise of like thousands of vehicles to over 3,15,000 vehicles were sold yearly. So this was a significant growth, considering that this time was a very early time for electric vehicles. And when we talk about electric vehicle, we also talk about renewable energy, because we all know that for for the sake of the environment also, and in terms of money also, we need to shift to renewable energies. And this is why electric vehicle is so successful, because we can make electricity through renewable resources. So as you can see, the growth of renewable energy has a significant impact on electric vehicle. So from 2000, in 2021 alone, 105 billion dollar is expected to be invested in US energy transition, and this is increasing day by day every year. So this is a good thing for electric vehicle and for the environment. And government initiatives and ongoing initiatives by even self-awareness by individuals are some of the factors which is leading to this EV boom. So talking about the innovation, so in our project, what we achieved was using a transactional data set also. We had we had achieved analytical. We were able to do analytical processes on that database. Generally, it is very difficult, but we were able to do with a mix of technology and data pipeline, which I'm going to discuss later in the slide. So, significance to the real world, as the topic suggests, like our reliance on petroleum, we need to decrease we need to shift from conventional sources to renewable sources of energy. So, our reliance on petroleum make us very vulnerable to price spikes, supply interpretations, and interruptions, as you saw during this Russia-Ukraine conflict. As the war evolved, the prices of oil started increasing because Russia was importing almost 70 to 80% of the oil all over the world. So that is the one of the factor. That's why we need to shift to renewable energy, because like they say, sun is for one sun, one energy. So that is in terms of solar energy. But yeah, we can also think of other energies, like which is available everywhere regardless of country wise. And second important factor, we need to decrease the carbon footprint, which is very harmful for environment. According to the Paris Environment Act, uh, till 2050, all the countries need to shift to complete renewable energy and decrease their carbon footprint to almost 0%. So that is the goal every country is trying to achieve. Okay, now to discuss about the project development methodology. So we wanted to do it in a way that we would have done it in any company, in any corporate environment. So to start with, we sat down and we asked questions from each other. What needs to be done? What is the aim of our project? So for that, we used concept boards to break down our task into individual stories, and to have a clarity of task and responsibility right from the beginning. And then this task and then these stories, we use Jira. So which is a Jira board, which is a issue management and a task management software. So we use that to track what we have done, what is the progress of our project, what needs to be done more. If there is any bug we realize during the course of our project, then we just raise a ticket so that everyone is aware of that. Then for source control, we used GitHub. Then for data modeling and modeling, we used MySQL Workbench and Raw.io. We used AWS ETL. We used AWS Glue for ETL tool, Redshift for data warehouse, and we use Python libraries like Pandas for cleaning and processing. For data visualization, we use Tableau, which is where we have made, as a data analyst, we wanted to show our we wanted to display a story, not only find facts and figure. We wanted to tell a story to the end user. So for that we use Tableau. Talking about the project workflow, so we first we had data from two different sources. One was from Kaggle and one was from Washington government data. Some data we wanted from Washington government data website, and some was available on Kaggle. So Kaggle one was, we just downloaded the data and use Python data pandas for some pre-processing, and we were good to go. But for the Washington government data, we use Crota, which is a you can say open source API calls through open source library, where used where we used API calls, and then we scrapped the data from Washington government data website. So that is how we did for Washington government data website. Then we used Amazon S3 buckets to store this data we cleaned, combining the Python and combining the both data from both the sources. Then we used AWS Glue for ETL part. More of a we use that to run jobs, from to load data from S3 buckets to Redshift, which is our data warehouse. So we were able to drop some columns there. So because ETL Glue gives us that liberty to give us the liberty to do so. Then we use Amazon Redshift, and that Redshift we directly connected it to Tableau. So we can make direct connections to Tableau. So that is one part. And for the MariaDB part, so some of the data to show, when I'll show you the dashboard, then you'll understand. So we wanted to tell user the story that why electric vehicle is very important. We wanted to show that part also. So that is a data that we wanted a scale, we wanted an in-RAM memory database. So that's why we used MariaDB. So for that data, as you can see, some external data sources, we collected data from some different external data sources. Then using Python we did the pre-processing, and then we loaded that data onto MariaDB, and through the ODBC server we connected the MariaDB and Tableau. So and then finally in Tableau we had data from the first pipeline and data from the second pipeline. So this is the data modeling of how we of our Redshift data warehouse. So as you can see, we have created a Snowflake schema. Our vehicle is our you can say the central table, and then we have a sales table, company table, location, and a geolocation, which is derived from a location table. This is the modeling for MariaDB. We have so here you can see, like, we have years, we have indicators, and we have so this is basic. This is a kind of a basic structure. I'll explain you to I can show you properly this when we'll move to dashboard. So for data pre-processing, how we did was first did data cleaning, then we did data reduction. We had to drop some columns, so we identified that, we dropped that column. Then data aggregation, we identified outliers, we removed that, and finally in the fourth step we had a standardized data. I'll take you to code walkthrough. This is just a snippet of that. Okay, so to our AWS implementation part, so we started from S3, loading our data into S3 buckets. We created VPC endpoints so that to make it secure, any other user other than us, nobody can access it. So for that we used VPC endpoints. Then this is glue jobs. So as you can see, this is a glue catalog. Here we created crawlers, as you can see, using S3. So we had to create two crawler, one for Redshift and one for S3. So we created two crawlers, and then using glue jobs we loaded data from S3 to Redshift. So this is how we implemented our AWS architecture. Okay, now I'll take you to the Tableau visualization. So what we have done is, to for better accessibility and for better reach, we have posted our code on Tableau public so that anybody can see. So this is the dashboard we have created. So